The topic is nested if. An if within an if is known as a nested if. When do we use this nested if? We use it when we want to check for many conditions simultaneously. Till now, whatever if statements we wrote, whether it was a single if or multiple else if, we checked many conditions, but they were written as else if and else if. But instead, I want to check many conditions simultaneously to perform one true statement. In that case, we go with nested if. Let's see an example for this. The problem definition is I have to input three integers into the variables a, b, c and check which is the biggest, whether a is biggest, b is biggest or c is biggest. I have some sample data. Let's see what should be the result of this. If I give the input as a as 5, b as 4 and c as 3, the output should be, it should say a is biggest. In the second case, 5, 6, 3, it should say b is biggest. In the third case, it should say c is biggest. Let's see how to do this in C. Okay, I have kept some part of the code ready. The problem definition is to input three integers, so I have declared three variables a, b, c. I have to take three inputs, so I have three scanfs and each scanf is preceded by a printf. Now, how do we check for this? First, if a is greater than b. If a is greater than b, does it mean that a is biggest? No. That it might be, you also have to check with what now? C. So, for this what you will do is put a pair of curly bracket. Inside this, put another condition. If, check whether A is greater than C. One pair of curly brackets for this. Then else another pair of curly bracket. For the main if, again one pair of what now? Curly bracket. Let's first check this. If A is greater than B as well as A is greater than C, then we can say that A is biggest. So, I will say printf A is biggest. Else indicates what? A is greater than B, but A is not greater than C. That means C is biggest. So, look at this now. Printf C is biggest. This is one part. Now, what if the first if is false? A greater than B. This is not true. That means A is not biggest. Left out is only between B and C. So, if check whether B is greater than C. If this is true, printf B is biggest. If this is also false, B is not greater than C, then look at this. Printf, we say C is biggest. Let's run this. 5, 4, 3. Which is biggest? A is biggest. Next. 5, 6, 3. B is biggest. Next. 5, 6, 7. C is biggest. Let's analyze quickly how this works. First time, I will take three numbers, A, B, C values as 5, 4 and 3. A is 5, B is 4, C is 3. How does it work? First time, A greater than B. Is A greater than B? Yes. 5 is greater than 4, so it enters the curly bracket below. In this, I have another condition, check whether A is greater than C. So, A is greater than B, so I also have to check with C. Is it greater? Yes, in this case, it is yes. So, it will go to the true part of the second if, it will print A is biggest. It will ignore the else, it will ignore the outer else part also and directly come to what now? Stop. Come to the stop part. Now, second time, I will give the input as 5, 6 and 3. How does this work first time? A greater than B, 5 greater than 6? No. So, it will not enter this particular statement at all. Now, it will check. Is B greater than C? Is 6 greater than 3? Yes. So, it will print what now? B is biggest. Third, 5, 6, 9. First time, A greater than B, 5 greater than 6? No. So, it will not enter all these statements, directly comes to the second else. If B greater than C, 6 greater than 9 is also false. So, it comes down, it will print C is biggest. So, what we have done over here is when one condition is true, within that immediately we are checking for another condition. So, this is called as your nested if. Whereas this else if is not nested, it is your regular multiple if else statement. The next topic is logical operators. We have seen how to use relational operators with your if statement. Now we will be using one more type of operator known as the logical operator with your conditions. We have two types of logical operators. The first one is AND, the second one is OR. AND is written as double ampersand, OR is written as two vertical lines, or we also call it as a pipe. Now, when should we use these logical operators? Logical operators are also used when you want to check for multiple conditions simultaneously. So, we saw previously how to use nested if to check for multiple conditions simultaneously. But a better way of doing that is by using the logical operators. Let's start with the first one, AND. The AND logical operator is used when you want to check for multiple conditions and all the conditions must be true. Only then it will select the yes direction, or it will do the true statement. Even if one condition is false, it will always go to the else part. So AND indicates all the conditions must be satisfied. Let's take one small concept for this. Let's take a table. We call this as a truth table. You have studied about this in your electronics, the same thing over here. So if the first condition is true and the second condition is true, the result will always be in the true direction. It will go to the yes part. If one condition is true and the second condition is false, it will go to the false part. If the first condition is true, it need not check with the second condition because at the first condition itself, the decision is made as false. So directly it goes to the false. So these are the three things. Now just for your clarity, if you want, you write it, but not required. So you can say F and T is F. F and F is also F. But the machine will, or the program in fact will not check for the second condition the moment it gets one false. So this is just only for our convenience. I have written it over here, but as I told you, you can skip these two condition statements. Second one. The second one is known as the OR operator. OR operator, when used with multiple conditions, indicates that if any one condition is true, it is enough to go to the yes part. Only if all the conditions are false, then it goes to the no part. So what do I mean by this? So I have first condition as true, second condition as false, no problem, it goes to the true part. And in fact, to be more clear with this, if one condition is true, it will not bother to check the second condition. The decision will be made over here itself. Next, first condition is false. Now it will check for the second condition. If it is true, still it does the true part. If first condition is false and the second condition is false, then it will take false. So F or F is F. When one is true and the second one is also true, true or true is also true. And again, as I said previously, it need not check for the second condition because if the first condition is true, it's enough to take it to true part irrespective of the second condition. But just for your clear understanding, you can write it. T or F is T, F or T is T, F or F is F, T or T is T. In fact, this behavior of not checking the second condition if the first condition is true is known as the short circuit behavior of the OR operator. Similarly, with the AND operator, if one condition is false, it will not bother to check the second one because if one is false, it will directly go to false. So this is known as a short circuit behavior of the AND operator. Okay, now this is how we evaluate the logical operators. Let's take an example for this. We had done that taking the input of marks scored in 3 subjects for a student, and we gave total average calculation. Based on the average, we said pass or fail. In fact, I had given the condition something like this. If average is less than 35, the result is going to be fail, else I had given it as pass. Now, if you look at this particular example, suppose if I give the input, like if I say 90, 90 and 30. Okay, assuming 35 is the passing marks. If I give 90, 90, 90, PCM, the average of this is going to be what now? 210 divided by what now? 3 is going to be roughly around 70. So the result of this will be taken as pass. So if you take it on average, the result is pass. But now let's say the pass or fail is not based on average. It should be based on every subject. So my condition is every subject should be at least 35. Only then it should be taken as pass. So that means now how many conditions should be checked? 3 conditions must be checked. How do I do it? One option is I can do it with nested if. But with nested if, we have to write many times the if-else statement. So a better way of doing it is by using the logical operator AND. How do we do it? So if I do it with the AND operator, I can simply write it in this manner. So we know the condition is all the statements, all the values must be at least 35. So I will simply say if P is greater than equal to 35, put an AND double ampersand symbol. C is greater than equal to 35 and M is greater than equal to 35. If all the 3 conditions are satisfied, only then give it as pass. Even if one condition is false, it has to give it as fail. Let's see how this works. First time, I will give 60, 90 and 80. What is the value of P? 60 greater than 35, is it true? Yes. Next, C greater than 35, is it true? Yes. 90 is greater than 35, second condition is also true. There is and M greater than 35. How much is M? Is 80. 80 greater than 35, true. So T and T and T, the result will be true. So it will give it as pass. Okay. Now let's take one more condition. So one more set of values. I will say 90, 60 and 20. What will be the result of this? First time, P is 90. 90 greater than 35? Yes. There is an AND. It will check for the second condition. 60 greater than 35? Yes. And M is 20. 20 greater than 35? No, this is false. So T and F, the result is always F. It goes into the else part. What have I given in the else part? Is failed. So it's going to give this as fail. Clear? Let's take another example. Suppose I give it as 60, 20 and 80. Now how is this evaluated? 60 greater than 35, true. And C greater than 35, 20 greater than 35, no, false. Now what it will do is it will not bother to check the third condition. From here it directly makes the decision of what now false and it gives the result as fail. You can also test it with the last one. I will say 30, 20 and 90. First condition itself is false. So it will not check for the rest of the two things. It will directly go to the else part and give it as false. Let's see the C program for this. So I've kept the code ready. I need 3 variables, 3 integer variables I have declared. I need 3 inputs, so I have given 3 scanfs. Now let's write the if condition with the logical operator. If P greater than equal to 35 and C is greater than equal to 35 and M is greater than equal to 35. If this is true, do what? If any one condition is false, do what? That is in the else part. Printf, what is the result? Is pass. If any one condition is false, then print it as fail. Let's check it for all possible values. First time, 90, 78, 99. All 3 subjects are greater than 35. I got the result as pass, correct? Yes. Next, I will say 78, 99 and 23. The third subject is fail. The result will be given as fail. Next, 67, 12, 99. Second subject is fail. So the result is still fail. So this is how you can check for what now? Multiple values and test whether your program works correctly or not. Let's take another example for the logical operator AND. We did that nested if example of finding the biggest of 3 numbers A, B, C. So we wrote if, within that we wrote another if, else, and then we wrote an outer else. So that's a very long way of doing the things. Now we can simplify this by using the logical operator AND. So let's do that. The problem definition is input 3 integers and find whether A is big, B is big or C is big. Now, when can we say A is biggest? A is biggest if it is greater than B as well as greater than C. So it should be greater than B and greater than C. So let's see how to write this now. If A greater than B and A greater than C. If this is true, printf, what is the conclusion? A is biggest. Else, if A is not biggest, can I say definitely B is biggest? No, it can be B or C. I need to put another if statement. So if B is greater than C, I need not check with A because I have already come to the else part. It means A is not biggest. So I'm going to compare only B with C. I need not compare B with A again. So I'm comparing A with B. A is not biggest. Then I'm comparing only B with C. That is enough to decide whether B is biggest or C is biggest. So if B is greater than C, then I will come to the conclusion, printf B is biggest. Else, if A is not biggest, B is not biggest, the only conclusion is print C is biggest. Let's check this. 5, 6, 7. C is biggest. 5, 4, 3. A is biggest. 5, 6, 3. B is biggest. So now you can see how easily we wrote it with the AND operator instead of using the nested if. But that doesn't mean that nested if is not at all useful. Nothing like that. It depends upon the problem definition. There are many times where we have to make use of what now your nested if. The next example is to input any one character and check if it is a vowel or not a vowel. Let's understand what we are supposed to do. Suppose I give my input as E. It's a character input. So I will give the input as E. So the variable A now contains the alphabet E. Is this a vowel? Yes, it is a vowel. So the next input I will say I. The value of A, variable name is A. Its value is I. Is it a vowel? Yes. Suppose if I say P, is this a vowel? No. If I say capital A, yes, this is a vowel. Now, how do we check for? Let's understand this. How many inputs we have? One input. How many vowels we have? A, E, I, O, U, lowercase. We also have capital letters A, E, I, O, U. So, in fact, there are 10 vowels. Now, the input what I have given, a single input, if I say E, the value of E, should I compare it? Should it be equal to all the 10 vowels or should it be equal to any one of the 10 vowels? It should be any one of the 10 vowels. So the logical operator over here is going to be OR. How do we write it? So let me write it in a small way here. So if A is equal to A, or A is equal to E, or A equal to I, or A equal to O, or is equal to U, or A equal to, I also have to check for capital A, or A equal to capital E. So like this, I should continue up to capital U. If any one of these conditions is satisfied, it is enough to tell it's a vowel. Only if all the conditions are false, then it takes it as a not a vowel. Let's see the code for this. Let's see the code for this. How many characters? Only one character. My input is going to be only one. I'm going to declare this as character A. A is a variable name. Now, how many inputs? One input. So, printf, enter any character. Scanf, %C, ampersand A. Now, how do we write the condition? If A double equal to small a, or A double equal to E, or A double equal to I, O is equal to U, or you can continue in the next line also if there is no space, or A equal to A, or A equal to E, I, if any one of them is true, what it should do, else what it should do. So if any one is satisfied, printf, it's a vowel. Else, printf, not a vowel. Okay. Let's take one small value and understand how this works. So my input A is I. So how does it check? What is the value of A? Is I. So is A equal to small a? No, A does not contain A. So one is false, no problem, it will go and check for the second one. Is A equal to E? Is I equal to E? No. So or it goes over here. A equal to I? Yes. A value is I equal to I. So it got one true. Now the moment it gets one true, it is enough. It will directly go to the true part and it will not check for the remaining conditions and it will give it as a vowel. Let's take another example. My input is P. How does it work? First, is A equal to A? False. Is equal to E? False. I false. O false. U is false. The remaining capital A, E, I, O, U, these are also false. So I got 10 false statements. False or false or false. If everything is false, it goes to the else part. So now it will give it as not a vowel. Let's check this. Run this and check the code. Enter a character. I is a vowel. Correct? Yes. Let's check for capital U. Is it correct? Yes. Let's check for P. Is not a vowel. So this is how your logical OR works. Let's take few more examples on the logical operators. The problem definition is you have to input any one integer and check that if that integer is a positive single digit integer or not a positive single digit integer. What do I mean by this? Suppose if my input is 7, what should it say? The output is it is a positive single digit. But if I say -7, it should say not a positive digit. What if I say 21? Not a positive single digit. So this is my problem definition. How do we do this? So if I want to check if a number is a positive single digit, which are your positive single digits? It is between 1 to 9. So you can check it like this. I will just mention the statements briefly. You can do the conversion. So input A, if A is greater than equal to 1 and A should be less than or equal to 9. So if the given number satisfies these two conditions, then you can say it is a positive single digit. If it is yes, you say positive single digit. If it is no, you will say not a positive single digit. Let's see this. The first input I will give is 7. Okay, what is the condition taken as? 7 greater than 1. Is it true? Yes. And 7 less than or equal to 9. Is it true? Yes. True and true. So it will go into the yes direction and it will give it as a positive single digit. Next input, I will say -3. How does this work? If -3 greater than 1 equal to 1, no. So I got one false already. It will not bother to check the second condition. It directly goes to the no direction and it will print it as not a positive single digit, right? So you can just try this on your own. I have given a hint of the logic. Let's take one more. So basically this is for the range. I'm checking for a range. So suitable is going to be AND. The next problem definition is take the salary of an employee as an input, one input. And if that salary is in the range of 20,000 to 50,000, then print the message eligible for bonus, else print not eligible for bonus. What will be the if statement for this? So if sal greater than equal to 20,000 and salary less than or equal to 50,000. If it is yes, print the message as eligible, else print not eligible. No calculations in this. I've just asked you to print the value. So this is also a range we are checking for. The input should be between this. Suppose if I give the salary as 30,000 as the input, how does it work? 30,000 greater than 20,000? Yes. And 30,000 less than 50,000? Yes. Since both are true, it goes to the yes direction and it will give it as eligible. Suppose I give the second input as 12,000. How does this work? 12,000 greater than 20,000? No, the first condition itself is false, so it goes to the no part. Third, let me take another input. I will take it as 75,000. How does this work? 75,000 greater than 20,000? True. And 75,000 less than 50,000 false, 1 true and false, so it will go to the no part. So you can try this particular code on your own. Another example, practice example. I want to input any 1 month as an integer. Suppose if I say 3 as an input, or if I say 5 as an input and so on, then I need to print the corresponding season. So if the input is 3 or 4 or 5, if it is equal to any one of them, print it as summer. Similarly, if the input, if it is equal to any one of this, print it as monsoon and so on. So I have given 5 solutions. So this is going to be a combination of multiple if along with logical operators. Do this as a practice example.